Welcome, everyone, and thank you for joining us for today's webinar. My name is Daniela Shimoni, and I will be your moderator for this webinar. Today, we're presenting the 2023 Threat Report, Cyber Attacks with Physical Consequences, presented by Andrew Ginter, the VP of Industrial Security at Waterfall Security Solutions, Rhys Maktemis, Director of Industrial Security at Waterfall Security Solutions, and Greg Hale, Editor and Founder at ICSSsource and ICSStrive. A couple of notes before I turn the webinar over to our presenters. The webinar is being recorded, and you will all get an email in a couple of days with a link to the recording. Our presenters will be taking your questions at the end of the webinar. Please submit your questions. You can use the Q&A button at the bottom of your screen at any time to submit a question. And now let's turn over the stage to our speakers.
Thank you, Daniela, and thank you everyone for joining us. You've kind of said everything I was going to say on this slide. We're talking about the threat report. I'd like to welcome Greg Hale, a guest. And I guess I'll advance and hand it over to Greg to say a little bit about, where this data came from to begin with.
All right, thanks, Andrew, and it's great to be here with everyone. We started ICSStrive about 2 years ago, and we found there was no real current database of incidents throughout our research and reporting on stories. And then, so with some help of some of our security friends, we launched the site. And with this site, it's possible to search for individual victims, search for sectors, attacks and incidents within specific sectors, types of attacks, attack groups. And to date, we have over 820 incidents on our database, and it's continuing to grow. We've added over 100 and so in the past couple of months. And the reason why we started is we write about these attacks all the time. So we are an independent third party focused on sharing impartial details with the industry to help everyone do their job better. And ICSStrive, essentially STRIVE stands for Security Threats, Regulations, Incidents, and Vulnerabilities Covered by Experts. And like I said, we've been doing this for about, just over 2 years.
Yeah, and let me add to that, Greg. What attracted my attention here was that, I've been in the industry for a long time. Incident repositories have come and gone, and I've always regretted losing them because, it's valuable information. And what struck me about this repository, your repository, was in a sense the business model. I mean, where did the other repositories come from historically? They came from somebody who said, let's do this. But someone whose main job was something else, a university professor whose job was doing, research and teaching, saying, let's, maintain this on the side, or a bunch of service providers, consultants, who said, our main job is securing things, but we occasionally have spare capacity. Let's spend it on this useful thing. And these repositories, the effort would go into them for a while, and then they would falter because the people involved had other priorities. What struck me about this was that you're a journalist. This is what you do for a living. You research these incidents, you write about these incidents. You are recording the information you've discovered about the incidents in this repository, in part as a public service, but in part because you need the information anyway, and you're always going to need the information. And so this struck me as something that had legs, something that was going to last for a long time, because it's not something that you're doing in addition to your main job. It, in a sense, is an integral part of your main job. And I thought that was very exciting, a repository that would last for a while instead of disappearing after another 2 years. But so that's the repository. I was going to hand the microphone over to Rhys. You're going to talk about the actual report that we based on the repository.
Absolutely, Andrew. Thank you so much. And, just a few more words about the database. It has been invaluable in doing this research. I've used it a lot. One of the great things I like about it is how approachable Greg and his team are. When I find some information, perhaps it conflicts with the report, I can contact him and submit new evidence. He will evaluate it. It's a great resource. So about the report. So Waterfall has our latest edition of our threat report available. This is something that has seen many iterations. It is not the first threat report. It is the 2023 threat report because it was released this year. And you can get it using the QR code right now or typing that link into your browser, waterfall-security.com/2023-threat-report. As always, the report tracks deliberate attacks and not errors and omissions with physical consequences, real world consequences where an incident, a cyber incident, causes shutdowns, equipment damage, or perhaps worse, to any kind of industry or business that we know best. So in this report, we have looked at industries that we deal with predominantly, and that includes things such as power, oil and gas, rails, water treatment, food and beverage, wastewater, agriculture, and mining. Things that can be modeled as a physical process, things that are traditionally considered critical infrastructure or operational technology. While we could have focused on other industries such as healthcare, one of the reasons why we did not focus on other industries is because we're just not as familiar with them. These industries are the ones we are most familiar with and the most comfortable reporting on. Another important criteria for these threat reports that we publish is that the information has to be in the public record and is independently verifiable by anybody with internet access. So that means that you can take anything in this report, plug it into your browser, go search for it yourself, and you should come up with the same conclusion that we did. And if not, by the way, please contact us. But we've put a lot of effort into this to make sure that it's designed to be the most conservative report, the most unambiguous, and where the incidents cannot be discounted. So these are of interest to anybody that deals with operational technology, cybersecurity. Next slide, please.
Well, before we go, Reese, I just want to add that, in this report, as we'll get into, but for the year that we're covering, it's 2022, we reported on 218 incidents, and 57 of which were attacks that ended up in physical consequences. And that compares to last year's reports, or the previous year, where there were 22 physical consequences and 64 incidents. Now, in the report, we'll talk about specific industries that suffered various physical consequences, but make no mistake about it, all industries are suffering attacks and all industries are facing physical consequences. I just wanted to be able to, point that out as well.
No problem. So before we go to the next slide, then, just a question out there for anybody. How many incidents do you think we had in 2010 when we first started covering these incidents with physical consequences? How many do you figure? 20, 30, 0, 1? How many had physical consequences? And the answer is, in 2010, we had one incident with physical consequences. We chose to start this report when Stuxnet became the first significant incident in OT cybersecurity, which destroyed 1,000 centrifuges. And it's a well-known incident, and it's a perfect place to begin, because this is where consequences really become real and crystallize for a lot of people in your mind when you think about OT cyber. Stuxnet was a big one. Next slide, please. And in 2011, how many did we have? There were none. Now, in 2011, there were many incidents that impacted OT that occurred where people attacked OT networks. What were the results there? Most of those attacks stole data, and they did not cause physical incidents. So we don't have any to count here in this report with our strict criteria. Next slide, please. In 2012, we had two. The two ones that matter in this case were hacktivist attacks on Iranian gas stations. This is where signs were defaced. Sorry, my mistake, where gas stations were shut down and unable to pump gas. And another incident that year that was significant was the Department of Homeland Security, which is now part of CISA, and ICSStrive published details of an attack. They did not identify a US power plant that was shut down, but what occurred here was that during regular routine maintenance, a generating station was shut down. And then when they went to bring it back up in a normal fashion, in a controlled fashion like they normally do, they realized they were a victim of a cyber attack, and it caused a 3-week delay in regular startup. And so they were not able to generate power for 3 weeks when they were expecting to. Next slide, please. In 2013, again, there was nothing. And in 2014, there was one more incident. This one was discovered from a report by the German BSI, which is very similar. It's a state institute, a government agency in Germany that is very, very similar to CISA. It's their equivalent. And the report does not say exactly what happened to the steel mill. All it says was, quote unquote, massive damages occurred. Now, what most likely happens to a steel mill of this type is if there is a shutdown, especially unexpected, these large smelters that smelt steel will cool down and all this metal will solidify inside the process. And so this usually requires a complete rebuild and complete restoration of the system, which can take a very, very long time. So when they say massive damages, this is what we estimate occurred. Next slide, please. In 2015, this was the very first Ukraine power outage attributed to a Russian attack, where the attack took out multiple distribution substations and affected 225,000 customers for up to 6 hours. Next. In 2016, we had a second Ukraine power outage triggered in Kyiv for 1 hour, again attributed to Russian threat actors who employ the Indestroyer malware. And they took out a single high voltage transmission substation. Then in 2017, suddenly we're starting to see the beginnings of a larger volume of incidents with physical consequences. Triton was the big one, where the petrochemical refinery in Saudi Arabia was shut down twice. Threat actors targeted their safety systems that are designed to shut down a process if a particular incident occurs that is unacceptable, would have unacceptable safety consequences in regular operation. They got inside these safety controllers and shut down the process, not once, but twice. We count this as one incident, one site, 2 shutdowns. And this was also the year where we saw the NotPetya attack. This is where a Ukrainian tax software package was infected with malware and spread it throughout its update mechanism. However, instead of staying confined to the customers of this Ukrainian tax package, unfortunately, it spread very, very wide. This was one incident with countless victims, thousands of them. One of them in particular of note was AP Moller Maersk. Their gateway terminals India shut down. Why? Not because they were using the tax package. It was because their head office in the Netherlands were using this tax package. And when they were infected with malware, there was an OT dependency in India at their port system level where they were not able to process paperwork. And that process normally occurs, through regular communication with their head office in the Netherlands over the internet. And therefore, they were unable to run their port because they were not able to process the paperwork to do so. Next, please. In 2018, the famous TSMC chip fab in Taiwan was infected by ransomware, and this caused a 3% annual revenue loss, quite large for them, the millions of dollars, when it halted production. Next, please. And in 2019, there were now 5 incidents. Now we're starting to really see a larger trend upwards. It's still relatively small, but it's building. And the most significant event in 2019 was the Norsk Hydro incident. And this is where Norsk Hydro shut down 4 sheet aluminum plants. Why is a hydroelectric company producing sheet aluminum? Well, it's a long story, but it's an interesting one, I promise you. It's an illustrative example of dependencies. First, their OT networks at their hydroelectric plants were deemed safe by the company and not at risk during the cyber attack, which infected their IT network. So they kept their hydroelectric generation running. Because smelting aluminum and producing sheet metal requires a lot of electric power, they also have a business and investment in aluminum production. And so their OT network in their aluminum smelters was deemed to be at risk, and there could be a possible contamination from their IT to OT network. And so they chose to run their aluminum smelters manually and keep production running manually without automation, which was painful but doable. However, their sheet aluminum plants, they deemed to not be safe to run, and it was too risky to run them. Even they could not run them manually, even because their automated processes were too complex to run manually. They could not run it without automation. And so they decided to shut down their aluminum sheet production. Next, please. 2020, boom, now we've got 18 incidents. This was quite a big year. Just going to pause here for a minute so everybody has a time to read some of these incidents. Most of them were on critical infrastructure and a lot of production. Next slide, please.
Well, I'm also going to add 2020 is the first real, as you say, the first time there's a large, serious amount of attacks. But this is also, we have to put it in some kind of reference here. This is also during mid-pandemic time frame. And so that's another component to add there. And I also find it interesting on the Honda attack that which was a ransomware attack that shut down production in 4 countries, in 4 facilities up to 4 days. And that was really, to me, it was a huge attack during that time frame.
Was that not, Greg, the Snake or the so-called ECANS ransomware attack on Honda?
I believe so, yes. And it was, and it just, like I said, it just shut him down.
And let me add, to my recollection of reading all these reports, every one of them was ransomware. This was the year that ransomware emerged as the driving force behind attacks that had physical consequences in the industries that we track.
Yeah, absolutely, Andrew. That matches my notes too. By the way, thank you for that, Greg and Andrew. 2021, we're seeing a slightly higher number now. We have 23 physical incidents with consequences to OT networks and operations. Nearly all were ransomware, except there were a few this time that were hacktivist attacks, which we've italicized. So for example, the Iran Rails attack here, this is where signage was defaced at railway stations across Iran, causing widespread chaos and panic. Basically, when people saw that all the trains were shut down on the signs, they believed it, and it caused a lot of confusion for several hours until the government was able to put out information trying to calm the public and reassure them that in fact the rail system was operating as normal. Colonial Pipelines, though, is the most significant event that, I would be remiss if I didn't mention it. Most people are aware of the details. This is where 40% of the East Coast gasoline supply was cut off for 6 days after a ransomware attack on their IT network. And the pipeline was shut down out of an abundance of caution by the company. And of course, much regulation and discussion at every level in the USA occurred.
I'll also add, Reese, that this is the first time that I noticed, at least after the year and looking at some of the trends, that it seemed like this was more and more attacks were hitting perishable goods companies, or companies that had to get their product up and out. And it seemed like ransomware attackers were going after some more of these companies. It's like the JBS attack and the new cooperative attack that, they were attacks that were hitting when the product had to move. And therefore, if you think about it, in a ransomware attack, it's they want to make their money, they want to make their ransom, and hitting a company at that point, they're more apt to pay the ransom.
You're absolutely right, Greg. I see more of them. I see Molson Coors. I see JBI Bike. All of these attacked large or mid-size companies producing goods of all kinds, especially foodstuffs and other items for commerce, and they prevented shipments and deliveries. Dam Brewery is another one. The Diamond comic book distributors, we're now seeing that these attacks are impacting publishers and food production of all kinds. It wasn't the new cooperative one, Greg, the one where ransomware threat actors attacked the agricultural sector, and this was at the time of harvest?
Exactly. And to their credit, from what we reported on, that they didn't pay, and they were shut down for a little bit, but they ended up not paying, then getting back up and running. But it did shut them down during harvest season.
Yes, let's go to the next slide, which is the big one to talk about, 2022. We have a lot of incidents in 2022. And this is where we start to see the numbers double from the previous year, if not more. To follow Greg's thoughts there from the last slide about ransomware threat actors targeting people at opportune moments, there's even more examples here. Macmillan Publishers was hit around the time that they ship all their books out for academic and students in university, post-secondary colleges. And this happened, in July, when they expect to deliver these things before the new school year that starts in September. And there's many more examples. AGCO was a big one. AGCO, you may not have heard of. AGCO is actually the company that owns brands such as Massey Ferguson, and ransomware threat actors targeted AGCO at the beginning of planting season, when everybody needs tractors and tractor parts. And this impacted all their production worldwide and shut it down for 15 days. And dealerships that sell these parts and specialty equipment for farmers around the world were not able to even book orders. So it impacted both their IT and OT network. And so this, we don't know for sure because we don't have the evidence, but this could be a very good example, perhaps, of an IT ransomware attack that leaks into the OT network and shuts down absolutely everything. There was more to talk about that's really important. One of them here is we start to see more attacks on oil and gas. And in this case, early in 2022, we saw port facilities that deal in midstream in shipping raw and refined large volumes of oil and gas products around the world. In this case, Market and Ball's Seatank and Evos Group in Europe and North Africa were badly impacted by ransomware events that crippled their operations at port. They were not able to load or unload product at port, and we're looking at weeks of downtime and production shutdowns for these operations. It was very significant, and it happened all around the same time. And Bridgestone was another notable incident that was quite significant, where Bridgestone was infected by ransomware at least one of their plants in North America. they made the decision to shut down all their operations in the Americas. That means North and South America. All 23 plants in the Americas were shut down for 10 days while they remediated and made sure that there was no more ransomware in their system and brought operations back up to normal production volumes. Next slide, please.
Well, before we go on, there's also
Sure. Go ahead.
In looking at all of these incidents, and when I started up the ISS source back in 2010, we knew that safety had always been an issue, but that cybersecurity was going to be, and sure enough, it was. But no, the industry didn't really suffer from, or at least that we knew of, from physical consequences as much as it was hit with reconnaissance missions, people going out and learning and trying to exfiltrate information from various OT organizations. And we wrote stories on that. But what country or independent contractor working for a country they just wanted to glean that intellectual property. But what we're seeing now is that laid the groundwork for networks that could potentially be hit with these physical consequences. And the Bridgestone attack to me is perfect example where that's one incident that affected 23 plants, and it was shut down for 10 days. I mean, I just find that to be an amazing evolution of types of attacks that have been going on.
Absolutely, Greg. Thank you for that comment. We have more attacks on the next slide for 2022. Some of the ones that I wanted to briefly mention were Profete, which is a bicycle company, which was impacted by ransomware. In this particular case, it shut down production like many other incidents, and they were not able to ship out finished bicycles or receive parts to build new bicycles. And because of this shutdown, they cited this as a major factor in their insolvency, in their bankruptcy that occurred only a month later. Now, to be fair, Profet did have some problems financially, and they were looking for a second round of investor injection into their business, and they simply weren't able to secure it. And this marks one of the first times where I've actually seen a company say publicly, not only did this deeply affect production and cost us a lot of money, but it actually bankrupted us. And the second incident that I thought was notable that is worth mentioning here is Empresas Públicas Medellín in Colombia, in South America. This is a very well-known and well-respected water company in Colombia. Well-respected because it's extremely well-run and known for being a great company to work for, and it supplies water to a lot of people. In this particular case, their IT network was hit by ransomware. Now, while it didn't affect water for most customers, they do have a segment of customers that are on prepaid water. And what this means is that they were unable to get water because their billing system and their IT network was compromised. And so this is a situation where there's some inadvertent or unplanned OT dependency on IT. They can't supply water to these customers without IT billing. Therefore, they had to truck in water to 28,000 homes because of this situation.
And if I may, it wasn't a situation where people weren't paying their bills. In this geography, in many jurisdictions around the world, both electric power and water services have shifted to a mode where you've got smart meters on every household, and the household pays in advance. And so they might want to pay in advance only by a couple of days. Why tie up their money to pay 6 months in advance for their water? And so once a week, they might put some money into the system and they continue to have power and water. Well, if the time came and they said, I always do this on Tuesday, and the system was down and could not take their money, they ran out of water, or the power was shut off in some cases on Wednesday because they hadn't paid. So this was, that's sort of the next level of detail on this. It's not that people weren't paying their bills. It's that they couldn't order what they needed, and they're used to ordering 1 or 2 days in advance, and you had to truck water into these homes. That, or try and find a way to reprogram their meters on an emergency basis.
Absolutely, Andrew. That's completely valid. And there was another incident previously, Johannesburg in South Africa, where 250,000 customers lost power for the same reason. They were on prepaid electricity plans. Next slide, please. And the last incident worth mentioning in 2022 is the Copper Mountain Mining Corporation, which shut down. Now, this incident is interesting, mainly because it's a very, very large copper mine in British Columbia, Canada, shutting down for 5 days. Details are sketch, but it appears as though a list of passwords to their system was leaked on the dark web a month before the attack. And this speaks to what Greg was saying before, where these ransomware threat actors are in the system, they're doing reconnaissance, they're looking out for things on the dark web, perhaps like a password list for OT or IT networks in order to get into the system. They're sitting there and they're waiting for an opportune moment to strike and cause a ransomware attack. This was pretty significant at the end of the year. And that's a wrap for 2022. So what do we project going forward into the future? If we look at the incidents starting at 2019 and take into account that there's a bit of an oddity around 2020 where we have a larger spike in incidents than the general trend, you can compare 2019, 2021, 2022, and see that in general, we have an exponential growth in incidents with physical consequences to OT networks and operations. And so if you calculate all the numbers and look at the numbers, we project that we will see 140 incidents with physical consequences in 2023. Next slide. And here is that projection going one more year forward into 2024. This is the curve that we're seeing, more than doubling annually. And this is a state change. Really, do we ever think we're going to go back to a year like 2018 where we had only one attack? Most of the incidents from 2010 to 2018 is just a little bit of noise. It's just, the noise floor here in the data. And suddenly we're starting to see a very deliberate trend upwards. And at 140% annual growth, we will see 4,500 attacks in 2027, affecting 15,000 sites if nothing changes.
Well, I'm going to say we're going to see this massive growth in incidents and physical consequences. Will those numbers project the way we're saying? Maybe, maybe not, but it's only time will tell. But I will say that we're getting more transparency in reporting, which I think helps in terms of learning about these things. But let's face it, if there's a potential out there, attackers are opportunistic and they want to achieve their goal, whatever it is, to make money. And so I think these attacks are real and they're going to keep growing. But will it be like that? Like I said, only time will tell.
Yeah, absolutely, Greg. I've been looking through a lot of these reports like you have. And it seems to me like there's a slight shift here and there. In general, though, with this strict criteria that we have in this report, we wanted to really get to this answer of what are the actual physical consequences, what are the real impacts that you will see in these types of industries. So let's move on to the next slide and talk about what we've seen in 2022. In terms of these impacts, the threat actors and so on. So who's behind all this? What can we see from the 2022 data? This is 2022 data here on the pie chart on the right. We see that predominantly almost all the attacks are ransomware attacks that can be attributed for sure. And hacktivists take up a small fraction, roughly 10%. And of those that are unknown, unattributable, many of these reports speculate, and it's speculation that they're most likely ransomware. So when you look at these incidents and it says so-and-so shut down for so many weeks because of a cyber incident, generally speaking, many people in the press, attribute this to ransomware. Is it? We don't know for sure. We've been as accurate as we can here with these numbers. There were no confirmed nation-state attacks. Sorry, if we can go back one more slide. There were no confirmed nation-state attacks in 2022. Again, for sure. So we didn't put them on the graph. There's been a lot of speculation as how many of these ransomware attacks are attributable to nation states. We didn't speculate here. These are the numbers that we're confident in. However,
I'm sorry.
Just one more quick thing here, Greg. One thing that is extremely important to keep in mind for anybody looking at these numbers and these incidents is that ransomware uses nation state tools. And, these are available to purchase on the dark web to anybody with money. You can go and buy toolkits. You can generate your own ransomware. Unfortunately, the information out there exists for you to go and become a ransomware gang. And this is, very serious in and of itself. And they're using nation state tools today that 5 years ago, nation states actually used on each other. And this is something important to keep in mind. Go ahead, Greg.
Well, I was going to say, 2 or 3 years ago, an attack was more of a, throw it up against the wall and see what happens. But in talking to a security expert friend of mine a year or so ago, he was saying that one of the biggest fears he had was that these attackers are becoming more OT knowledgeable and being able to go after OT systems with understanding, whether it's through IT or directly into OT. And that was a big fear he had. And it seems like that is becoming more true, that attackers are getting more OT knowledge.
Okay, I got to rush through the next couple slides a bit quickly to stay on time. Let me go to the next slide. So who's being targeted? Countries. Interestingly, this year we're seeing slightly less proportion of incidents affecting the USA and more on Canada, Germany, the UK, and so on. This is consistent, though, with previous year's distribution. Is this shields up in the USA, this message from CISA that's resonating and resulting in less incidents? I'm not sure, but here is what we saw in 2022 in terms of the proportion of attacks where the victims were in these countries and geographies. Next, please. And who is shutting down? These are the industries most disproportionately affected by these incidents, which are mostly ransomware. We have transportation, discrete manufacturing, which does comprise a lot of industries, including all kinds of manufacturing facilities, and food and beverage, again, which is similar to manufacturing, but has a slightly different process, which we've categorized differently. Another important thing to see here is that, surprise, actually, oil and gas is still being hit a lot by ransomware and cyber threat actors. Why is this a surprise? Because they have very large resources. They're wealthy businesses. They have been dealing with these kind of threats for a very long time. And the government is still warning us this year and last year and previously that oil and gas will be a target. It's interesting to see that they're still being victimized by ransomware and cyber threat actors and shutdowns. TSA has put out some new messaging. It's very important. And one of the things that they remind everybody is that the goal is to keep OT running at necessary capacity, even if your IT network is compromised. And so this situation of OT dependencies on ITs is still reoccurring, and it's important to look hard at these dependencies and make sure that your OT can keep running no matter what happens to your IT network. This is what we do as OT cybersecurity practitioners, is keep things running and protect the safety and operations of our systems. Any other comments, Greg or Andrew? Over to you, Andrew.
Okay, and the report, talks about the bad news. That was the bad news. We're looking at lots of attacks. We're looking at attacks growing rapidly. There is good news in the report. One of the developments last year was the strategy from the US Department of Energy called cyber-informed engineering. I call it security engineering for short. What is it? Well, classic example. If your life depended on a massive boiler, a 4-story boiler, that you're the technician maintaining a 4-story boiler, and your life depends on this boiler not blowing up in your face, how would you prefer to be protected? Would you like a spring-loaded valve or 3 on the boiler? A valve where if the pressure in the boiler gets too high, a steel plate is mechanically pushed against a spring, the steam is released, and there's no explosion? Or would you like a longer password on the PLC controlling the furnace? Most of us would like the valve, thank you, or 3 of them, because it's unhackable. This is an engineering mitigation. Here's the thing. Where is an overpressure valve? An overpressure valve is being used, in part, to prevent physical consequence due to any kind of misoperation of the boiler, including cyber attacks. It's a way to address cyber risk. Where's the valve in the NIST cybersecurity framework? Where's the valve in the IEC 62443 standard? None of these standards talk about engineering grade mitigations for cyber risk. And, the strategy is a strategy. It's not a recipe. It says we need to develop a body of knowledge. It doesn't say what is the body of knowledge. The good news is we don't have to invent all this stuff. A lot of this knowledge exists already. Security PHA review is out there, published by the ISA, written by the folks at Connexus. It talks about how to use the results of an OSHA style process hazard analysis or HAZOP study to use those results to address cyber risk to safety systems, to use unhackable mitigations to prevent safety consequences due to cyber attacks. CCE, Consequence-Driven Cyber-Informed Engineering, is a book from Idaho National Labs. Most of it is on risk assessment, but it has 3 or 4 chapters on risk mitigation, and they talk as well about various kinds of unhackable mitigations. The classic example they come to a couple of times is manual operations, which you heard about with the smelters that were being operated at Norsk Hydro. If you do not trust the strength of your OT security and your IT network is compromised, then shut down your computers, shut off all of the OT computers and operate the process manually. A third body of knowledge that's out there is my book from a couple of years ago. And, my book, in a sense, is focused on something a little different. SPR is focused on preventing unacceptable safety consequences. Countering cyber sabotage, is focused on protecting equipment, is focused on, again, preventing unacceptable consequences. But what happens if an overpressure valve triggers and releases the pressure in the boiler? Well, the power plant turns off because we want to prevent an explosion. What happens when protection equipment kicks in and says, there's an over voltage condition on the transformer? What happens? It shuts off the flow of power so that we don't damage the transformer. Both of these approaches, SPR and CCE, are great for preventing those consequences by shutting down the process when we are about to suffer unacceptable consequences. SecOT, Secure Operations Technology, is sort of the other side of the coin, saying, well, it's great that we've shut down the process so nobody dies. It's great that we shut down the process so nothing gets damaged. But we didn't want to shut the process down, did we? This is critical infrastructure. We're supposed to keep the lights on. And so SecOT is focused on preventing network engineering, it focuses on network engineering mechanisms to prevent attacks getting into networks in the first place to put them at risk. Concrete example, what is network engineering? The EPRI approach is one example. This is the North American Electric Power Research Institute. They were asked many years ago to figure out how can we safely connect vibration monitors from our massive, very expensive steam turbines into the cloud so that the vendors can analyze and optimize maintenance. And they can, and the risk was that, you know, the bad guys would get into the vendor's cloud and come back into the vibration monitoring devices on the turbines through the internet, through the connection to the cloud, and now compromise operations in our control network. And they said, look, you can do this. What you do is an engineering study on the equipment, make sure it's truly monitor only. It's not physically possible to control anything with this equipment. And then connect it straight out to the internet, connect it to the IT network, connect it to a DMZ. Do not connect these monitoring devices to the control network for the power plant. Send the data out to the cloud, benefit from optimizing maintenance, reducing maintenance costs, you know, saving money. But if the cloud is compromised and these sensors are tampered with, there's physically no way to propagate the attack from the sensor into the control network because there is no connection. This is a way to do safe industrial internet. You know, there's been other sort of steps in the direction of network engineering that we're seeing. This is sort of a new field. The goal is to keep operations running, even if your IT network is crippled. The TSA said in that many words, this is your goal. And to do that, they said, you've got to be able to, in an emergency, separate the IT and OT network. This is their approach to network engineering. They don't call it that, they call it something else, but they said you've got to be able to separate these networks so that your pipeline, in this example, can keep running even if IT is compromised. And what that means is that we cannot have any part of physical operations depend on IT resources, because the IT resources are going to be crippled if you cripple the IT network. So there are steps being taken in this field. To me, network engineering is the most interesting part of cyber-informed engineering. A lot of the techniques, overpressure valves, you know, centrifugal clutches, are in a sense very old technology. They're still very useful, but what's new and developing is network engineering. And one of the things that is being figured out in network engineering, one of the concepts is, you know, people have written for a long time about the difference. What's the difference between an IT network and an OT network? Oh, well, OT networks are harder to patch. OT networks are hard to put antivirus on. OT networks are hard to encrypt. These are all superficial differences. These differences that have been documented forever, they're superficial. Let's imagine we had a magic wand and we could wave the magic wand and we could magically patch everything. Bring all the versions right up to the latest version, all the operating systems up to the latest operating system, put antivirus everywhere, even on the operating systems that don't support it, encrypt everything, wave that magic wand. We would still need to manage our OT networks differently from IT networks because of the consequences. The worst case consequences of compromise on an OT network are casualties, loss of life, damage to very long lead time, very expensive equipment, production outages. Here's the thing, we cannot restore human lives or damaged equipment from backups. So this is the intrinsic difference. The difference is consequences. Even if we had the magic wand, there would still be a difference. And this difference is starting to be, you know, once you know to look for it, you can see it in the advice that's come out, you know, reasonably recently. NERC version 5 going forward defines low impact, medium impact, high impact assets and networks entirely in terms of consequence. The ANSI standards in France define the criticality of networks, class 1, class 2, class 3 networks, they call them, almost entirely in terms of consequences. Even 62443, you know, 62443-3-3 that talks about security levels is being revised, and the definition of security levels is being changed to take consequence much more into account. It's all about consequence, and it's all about consequence boundaries. The single most common kind of network engineering that we see deployed are unidirectional gateways. That we see recommended, you know, by these standards are unidirectional gateways at consequence boundaries. Not everywhere through the network. at the boundary between the OT network and the less consequential IT network, at the boundary between the OT network and the internet. These consequence boundaries are where you put unidirectional gateways. The gateway hardware is physically able to send information in only one direction, from the industrial network out to the business network. The software makes copies of servers. If you've got an OPC server on the industrial network that you need to provide, that data to the business network for optimization purposes, the software logs into the OPC server, gets all the tags, all the values, typically once a second, pushes them through the weird one-way hardware, and on the other side stands up an identical OPC server. Anybody on the outside network who needs the OPC data asks the copy for the data and gets the same answer as the live system would have given without ever sending any message back into the industrial network. Here's the thing, all cyber sabotage attacks are information. If no information can get through the hardware, no attacks can get through either. This is a mature technology. If you open the lid on it, you'll see a physical divider down the unit. The circuit boards that do the transmitting and the receiving have nothing in common. You can run your finger down the divider and visually verify there's no cross connect. The only cross connect is on the front panel, that fiber optic cable from one side to the other, sending one way. Fiber optic transmitter, a laser on one side and a photocell receiver on the other. This is engineering grade unidirectionality. It's a mature technology. There's lots of connectors out there to make copies of OPC servers and Pi servers and Orchestra historian servers and MQTC servers and you name it. There's lots of ways to make copy of useful data out to the IT network. And again, a mature technology has been around for a long time. It's a network appliance. It's self-contained. Everything runs in the appliance. Has a web-based user interface. It's everything you expect. So network engineering, an emerging field, but it's not rocket science. It's straightforward. Here is a more complicated example of network engineering in practice. The Maersk scenario. NotPetya crippled the IT network, crippled the system that tracked the EDI files that said where every container, hundreds of thousands of containers, where all of these containers went. The ships did not run aground. The OT networks on the ships were intact. The cranes did not go crazy. The OT networks in the ports were intact. The cranes could lift the containers off the ships and put them onto the trucks, but they could not print the information for the truck drivers about where to send the container. And so everything stopped. So when you analyze this, it's not you have an OT network controlling the ships, preventing them from running into rocks. It's not like we have an IT network that just does business. We've got these interdependencies. Really, we don't have two networks. We have three networks. One of them is safety critical. Keep the ships off the rocks. Keep the cranes from killing anyone, dropping boxes on people. So one of them is safety critical. One of them is business critical. Pay payroll and pay our suppliers. And the third one is reliability critical, because we cannot operate our shipping unless we can print those labels. And so how do we do this? How do we manage this? We put a unidirectional gateway in at the safety critical to business critical boundary so that we can keep running the ships, we can keep running the cranes. There is no risk that those physical systems are going to kill anyone. And we need to do something about the container tracking system, don't we? Put it on its own network. Put it on a virtual machine so that if there's an incident, the incident responders make a beeline for the container tracking system, restore from the latest known backup, takes half an hour, replay the transaction logs, bring it back up to date, and now it's up and running again. But the rest of the IT network is crippled, which means a lot of the network engineering principles that we applied to the boundary between IT and OT, no dependencies, no shared trusts, all of those principles need to be applied at the reliability critical to the IT boundary as well. It does no good to bring the container tracking system back up if it depends on an Active Directory system that's crippled. We have to make the reliability critical network independent of IT, just like OT is independent of IT. And then when we restore, OT stays up the whole time. We restore the container tracking system. We have resilience in less than a handful of hours. Everything is back up. It's an outage, yes, but it doesn't make the news. It's not newsworthy. A lot of these concepts are coming out of my new book. I mentioned the old book. This is a look into the new book, looking into the future, not looking into the past with the threat report. And, I've blasted through this at lightning speed because we're running a little bit late. The punchline here, the world has changed. We've gone from a theoretical problem to a real problem. Incidents with consequences are increasing dramatically and appear to be poised to continue doing that. Nation state attack tools are coming after all of us in the hands of ransomware because they bought them. And what I think we need to do is look hard at cyber-informed engineering, look hard at network engineering. This is something new in the world, a new way forward to deal with cyber risk, in addition to all of the the cybersecurity stuff that we've done for the last 20 years. Reese and Greg, I've blasted through this. I wanted to shut up and give you a chance to chime in.
Well, I'm not gonna repeat a lot of the things you say, especially in this slide. But I will say that you talk about incidents, and and the biggest fear is ransomware. I mean, the biggest, and it's going to be here. It's going to be here forever, and it's been here, and it's going to stay. But I also say there's going to be other attacks that are coming our way that we haven't maybe even heard of yet, and other attacks that are growing are like supply chain attacks. And so it's more than anything else is understand what has been going on. And then just keep growing your program to ensure that you stay as secure and up and running and resilient as possible.
Okay,
I mean,
go ahead.
A lot of questions. Perhaps we should address some of them now.
Sure. So let me say we've got a couple of questioners who really are quite verbose. I'm not going to name names, but a lot of the stuff in the Q&A panel here is more comments than questions. Let me address a couple of them. One comment was that we fumbled the TMSC incident in 2018. It was actually $5 billion of outage, not 5 million. We'll double check that. Thanks for that. Another comment, let me see, there was a comment about the Florida water supply attack. That was not counted in any of these because it was a near miss, because there were no physical consequences. There were no boil water advisories. The taps did not run dry. The problem was detected before there could be a physical consequence. So yes, it was important. It was actually mentioned in last year's threat report, not this year's, as a near miss, not as an actual incident. Daniela, do we have? Oh, you got one? Go for it.
Yeah, somebody, anonymous attendee asked, what do you think about AI and cybersecurity? This is a very general question, but I wanted to mention that AI is emerging. It emerged this year as a big factor in everybody's lives, not only in cyber. What do I think about it? I think that AI is part of the tools, techniques, and procedures that an attacker can use and cause cyber incidents. It's also useful as a defense mechanism or to be built into defense products. However, there's a lot of speculation, a lot of change occurring in AI right now in the industry, and I believe that it's changing so rapidly, it's very hard to say what exactly it all means at this time. So I think it's something to look forward to. We will have a better idea after we review all the incidents that will go into next year's report, and we will be able to comment, I believe, on AI in more detail.
Absolutely. I mean, we have Waterfall has research projects underway. We are, using the AI tools, trying to use the AI tools the way that an attacker would. It's not just us doing it. There are dozens of research projects out there trying to figure out how much trouble are we in using these tools. The lessons so far, the attackers who have been using AI seem to be using it primarily in terms of social engineering, producing very convincing phishing attacks, very convincing messaging, very convincing emails, because that's one of the things this current sort of conversational grade of AI does well. So we are seeing that out in the world. And of course, all of those are attack vectors that can lead the bad guys into IT networks and ultimately closer to the OT targets. We're likely to see some leak over effects. How much is very much an open question.
Okay, thank you. Would you like me to, I see some more questions here.
Sure, go for it.
A couple of more, okay. We have, was the water supply attack just mentioned not recategorized as operator error rather than an attack?
So yeah, we looked at that, Andrew. The jury is still out on this. Talking about the Oldsmar attack, very recently in April, a former manager that used to work for the city said, oh, this wasn't actually an attack. It was just somebody fumble fingering the controls at the HMI. And yet at the same time, the FBI and the local sheriff's office put out a bulletin saying, well, all we can say for sure is we don't have enough evidence of anybody entering the system externally. So we really just don't know. And they said the investigation is still open. So at this point, what do you draw from this? Either way, it's still a near miss. Like Andrew said, it did not result in physical consequences. And so it's just simply not included in our report, but it still has a lot to talk about, a lot to discuss, and it's still very relevant to our industry.
One of the things about the water attack, and whether this was a cyber attack or not, is it brought up some really interesting components about the water industry, and showed just how vulnerable the water industry is, and the water industry is so undermanned and under-secured that more and more has to be done to help protect that vital area.
Absolutely. And there's been more attacks that did not make it in the report where there were near misses on water. There was a young kid, a former employee in Kansas, who was arrested and prosecuted only last year, where he kept credentials from his time during employment in the insider attack. Again, did not make it in our report because they caught him and stop the damage before it caused any outages. So these situations are still occurring. There's more of them. And I believe if you check Greg's ICSStrive database, there's a lot of valuable information there. And there's also some that has been mentioned in previous webinars and reports and talks that have been given by Waterfall and by all of us. We've mentioned these incidents sporadically here and there, which you can go find on our website.
Okay, thank you. I want to address another question. Based on the existing database, are the latest cyber physical damage quantifiers reliable?
So are the latest cyber physical damage quantifiers reliable?
Yeah.
Okay. We have not put together in the report, we did not try to add up all of the, what's the right word? All of the dollar amounts of damages. We've mentioned them in the summaries, but no, we haven't tried to add them up. And when we've mentioned them, it's not like we've gone to the site and said, okay, how much did you spend on cleanup on the IT network? How much did you spend on cleanup on the OT network? How much did you lose because of lost production? How much? And then ask the question, well, should the IT cleanup really be considered part of the OT incident? We didn't split that hair. What we did was we went to the public reports, and if there's a public report from a credible source that says, look, it was $5 million or $5 billion, that's the number we used. Finer granularity than that, we don't have. I hope that addresses the question. Reese, Greg?
Well, the information that we get for these attacks and these damages and all that stuff, as Andrew said, we're going through public records. We're going through and finding out as much information as possible. So the information that we have on this is as reliable as that can be. And we're not really printing speculation. We're printing more facts than anything else.
Yeah, I mean, ultimately, some other reports out there put a lot of private information in them. They confuse what's public with what's private. Again, going back to the way we built this study and this threat report analysis, it was designed specifically to eliminate that difficult confusion. You know, if you're starting to say, okay, we got 10 incidents in 2010 and not just one, and because we've confused, you know, private information that we've gleaned from perhaps customers or contacts that we have, then we can't report on it because it's private information. So we can't share with you the details of what we learned. We can only say, oh yeah, there was 10 shutdowns. Well, that's less useful than if we can say, here is the information that we know about. This is where you can go find it. Here's the URL. The appendices at the end of our threat report. For the first time in this year, we've published everything we know about since 2010 in a big table. You can go look at that. And we invite any comments. If you find any that we don't know about in the public record, please let us know. And we want this to be as consistent and reliable as any other report out there. And what that means is the incident count is lower than perhaps some other reports, but that's because we have a very strict inclusion criteria.
Okay, thank you. Let's address another question. Which parts of cybersecurity are in use for smart grid security process? What could you suggest for an electrical engineer who wants to dive into cybersec in the energy sector?
The smart grid is, in a sense, it's a whole other webinar or 6. I mean, smart grid starts with what is the smart grid? I'm sorry, it's a marketing phrase. It nowadays means the entire electric grid. It used to mean something else. Now people are using smart grid to mean everything. So, you know, how do you do cybersecurity for the power grid? Well, NERC is part of that answer. You know, there's other standards out there. There's, you know, it's a very big question. Let me look at the question again. What parts are in use, are currently in use? And, you know, what would you suggest for an engineer who wants to get into security in the electric sector? Where to begin? What's in, you know, what is being done? There's a lot of encryption going into the smart grid. A lot of the smart grid, a lot of the old definition of smart grid was cloud stuff. And so there's a lot of encryption going into the smart grid. A lot of, you know, I'm sorry, a lot of people say, look, I have a smart meter. And you ask, great, how have you secured it? And the only answer you get is about encryption. Encryption seems to be the answer to every question. You and I know that there's much more to security than encryption. If you steal the password and you take over one end of the encrypted connection, you can send commands to the other end inside the encrypted connection. So, you know, account control, permission control, consequence boundaries, all of these are relevant. It's you know, it's a bigger space than just encryption. So a lot of the information out there is very confusing. If you want to get started, you know, ultimately there's a lot to learn. You know, read the standards, you know, start doing the stuff, learn about attacks. You know, I would give you, let's say, you know, a handful of resources. I would suggest maybe start with Waterfall's top 20 cyber attacks report. Go to the Waterfall website under resources, ebooks and white papers, scroll down a bit, find the top 20. It describes how a whole range of modern attacks work. We cannot defend systems unless we know how they're being attacked. look into them. If the terminology and the approaches in there don't make any sense to you, dig into the technical details, understand TCP communications, understand how crypto systems work, do the research on the technology to understand the attacks. And then I would recommend, reading stuff like, the IEC standards. You actually have to buy them if you want to read them, or sign up as a member of ISA, and then you can read them for free online. It's cheaper that way. I would recommend the ANSI standards in France, ANSSI. Cybersecurity for critical infrastructure. They're free. There is an English version available, and they're surprisingly readable. And I would recommend the 3 books that you saw on the slides earlier. SPR is a great resource on securing safety systems. CCE is sort of the modern approach to cybersecurity that everyone's talking about. SecOT is sort of the foundation of network engineering and even information engineering. That would be my recommendation. Reese, Greg?
Yeah, I'm good with that explanation, Andrew.
Okay.
Okay, thank you.
Okay.
So yes, Andrew.
I was just going to say, I saw a question earlier about VLANs that I wanted to address, but I can't find it. Is it still here?
I addressed that with a written response, Andrew, but
okay.
Go ahead if you'd like to address it again. The question was basically like, is a VLAN not sufficient to protect your networks?
Yeah, and the question is, how are you using the VLAN? Generally speaking, people that I work with do not regard a VLAN as adequate protection at a consequence boundary. By all means, use VLANs within the industrial network, use VLANs on the IT network, but at the consequence boundary between an internet DMZ and the OT network, between the OT network and the IT network, no, you need to put an engineering grade solution in there when the consequences of compromise are unacceptable. And this is a topic I address in my new book. There's no such thing as a one-size-fits-all solution. VLANs may be entirely appropriate in a small shoe factory. Why? Because nobody can die in a small shoe factory. Okay, there's mechanical interlocks that prevent anyone, repairing equipment from having that equipment fire up on them and kill them in the process of doing work. A VLAN may be entirely appropriate for a small shoe factory, even at the IT-OT interface, because there is no reliability critical network. There is no safety critical network. There's only the business network. The consequences of the shoe factory going down are some cleanup costs and scheduling after extra shifts to make up lost production. These are business consequences. You can buy insurance for this. A VLAN might make perfect sense there. You don't put it in a power plant network where the consequences of compromise, the worst case, are safety consequences, and every case is a critical infrastructure outage. At that consequence boundary, you need something stronger. So this is sort of my long answer to the question.
Okay, so we already passed the end of the hour. So thank you, Andrew, Greg, and Reese. It was a very informative session. We will follow up on all questions and send a follow-up email to all registrants, including information on how to access a recorded version of this webinar for review or to share with others, as well as the registration information for the upcoming webinars on other topics. So thank you, everyone, and have a great day. Andrew, Reese, Greg, some final words from your side.
Thank you, Daniela. Thank you, Reese. Thank you, Greg. Thank you, everyone, staying with us.
Thank you, everybody. It's great to have a chance to talk today.
It was good. It was a good session.
Thank you. Bye-bye.
Take care.